Hi Professor, my name is Chen Han Wang. I'm recording this video to explain my code used for my thesis using technical indicators to forecast the stock price movement in the future. So I chose to use Excel to do most of the coding. The reason why is that it's very easy to use, and then it's just enough for this thesis. I try to use Python and compare it to Excel, and just I feel like Excel is already able to handle most of the work. So, and it's very easy for other people to understand. So that's why I'm gonna present it with Excel. Okay, so I'm gonna do a little review on my thesis. So what I've done is that I researched a couple technical indicators, and then I conducted back testings using historical stock price data. So in this case, I'm using Apple's 10 years trading data as an example to illustrate my code, and then I'll conduct back testing first, and then I have three indicators that I'm going to introduce. I'm going to research what is the forecast accuracy of each individual technical indicators, and then I'm going to come up with my own model and see if my own model can yield a superior forecasting accuracy. So I'm going to start from the backtesting part. The backtesting's raw data. This is the raw data. It's downloaded from Bloomberg. It contains a stock's daily stock prices, and then states the market open price, highest price in the day, lowest price in the day, and close price of that day. And then there's some simple moving averages, and then volume. So I will start from here. So this is my data input. And then the first technical indicator is typical price. So it's very easy to calculate. It is calculated as the average of high price, low price, and close price. And then what we're going to do is I'm going to compare this to the moving average of 20 days. So if the average is greater than the simple moving average, then this is considered as a sell signal, right? And then if the average is smaller than the simple moving average, it is a buy signal. So here's the raw data that I just shown you, and then the direction is the true direction. If we go through the formula, it's just that use the next day's price compared to the current day's price. If the next day's price is going up, that means the real direction is going up, and then we're going to compare this to the signal that generated by the typical price indicator. So the formula here is just doing the average of the open price, high price, and low price. Close price, high price, and low price. And then we're going to compare the average to the simple moving average. If it's smaller than that, we say it's a buy signal. Otherwise, it's a sell signal. And then another important concept here is what is I'm gonna freeze roll so it's easier to view. This is how I document the results. Basically, it's positive, true positive, false negative, and true negative. So basically, when the indicator generates a buy signal, and in this case, the true direction is going down. So that means if I use this technical indicator, it's gonna suggest a buy. But if I do that, I'm gonna lose money because the real direction is down. In this case, it's a false positive. And if it's true positive in this case, that means it generates a buy signal, and it did really go up. So in this case, it's a true positive. And then I summarize the results here. Out of a total of around 26,000 days, and then here's the true result. Sorry, here's the signals generated by the typical price, and then here are the results. We can see that the accuracy is not very good. It's below 50%. So that means using typical price alone, the accuracy is not very good. Okay, and the second one is CMI. I gotta hurry up a little bit because it's already 5 minutes. So the formula of CMI is a volume based. So it compares the accumulation distribution over the volume, and then the accumulation is also volume based data, compares to the close price and then open price, high price, and low price. So I'm going to go through the formulas really quick. So starting from here, here's the accumulation that we just went over. It is the close price minus the average of high price and low price, and then the associated volume is just the accumulation value times volume, and then here's just the simple sum of the 13 days, as you can see, the sum of the 13 days accumulation volume, and then here is the sum of the volume itself, and then we're gonna divide the sum of the accumulation volume to the actual trading volume, so we get the CMI value. For the CMI value, is that the rule is if the absolute value of it is less than 0.1, that means it's no signal, it's too small to generate a signal. If it's greater than 0.25, we say this is a strong buy, and then if it's greater than 0.1, that's a buy signal. If it's smaller than negative 0.25, that's a strong sell. Otherwise, if it's between negative 0.25 to negative 0.1, then it's a sell signal. And then, so this is the signal we generated, right? And then similarly, we're going to conduct the directional check. So in this case, it generated a buy signal, and then we're going to compare the buy signal to the actual price, the price movement. Let's see, we can see the close price here. The current day is 20.6, and the next day is 19.5. So that means the actual direction is going down. But we generate a buy signal. That means this is a false positive. The concept is similar for every indicator. So I'm gonna save some time to not go through every one. And then here's the table presenting the whole results. Again, false positive, true negative, things like that. And then we can see the overall accuracy is 51%, right? It's not ideal, it's just slightly better than random. And then the last one is Bollinger Bands. Bollinger Bands is just a strict concept of standard deviation plus the moving average plus two standard deviation. So it's very easy to understand. So first of all, I will calculate the standard deviation, right? Calculate the standard deviation, and then we'll calculate the upper band, which is just the simple moving average plus 2 of the standard deviation, and lower band is just subtracting 2 standard deviation. And then we can generate the signals if the close price is greater than the upper band. That means probably the price is too high, so we generate a sell signal. Otherwise, it's a buy signal. And then the accuracy is similar. In this case, when we look at this day's price, right? So it's 19.5. The next day is 19.3. So it's actually going down, right? And then we generate a sell signal. So that means we're right. So we have a true negative. And then the results are just summarizing it here. As we can see, Bollinger Bands itself, it's not a great indicator. It only generated 47.6% accuracy. Okay, so this is the first part. And then the second part is when I gathered more data points, I collected stock data for Walmart, Apple, and JP Morgan with a longer period of days. And then I summarized the results for each single technical indicators. You can see the accuracy is presented here. It's not good, it's not great. And then so what I come up, I'm gonna introduce my model now. So my model is a combination of the three technical indicators. So I documented all the results here. What is the value of the indicators from each indicator, and then I'm going to assign numerical value to it. So that means if it's a buy signal, I would assign 1. If no signal, I'm going to assign 0. If in some cases it's going to be some strong buy signal, I'll give you 1.5. If it's a strong sell signal, I'll give it negative 0.15. And then I'm going to sum up the all the numerical indicators. Sorry, my cat. I'm going to sum it up, and then once I sum everything up, so I will have a band between negative 3.5, so means all three indicators is suggesting selling, and then the other side would be 3.5. All the three indicators are indicating a buying. So in this case, it is a little like a classification, right? And then I will have more labels so that I can better compare my results. So here are the end results. We can see that once I combine the three indicators into my model, I can, in some cases, I'll be able to find some accuracy greater than 50%. All the highlighted parts, they're greater than 50%. So that means my model is superior to using any of the individual technical indicators, which I think is an improvement. Okay, I'm gonna start right now. It's 11 minutes. Thanks for watching. I'm gonna record another video to explain my using my paper to explain my thesis. Thank you.